A 5,000 kilogram car is traveling at a speed of 30 meters per second. The driver applies the brakes and the car comes to a complete stop after skidding for 60 meters. Calculate the average force applied by the brakes to stop the car. So we have the mass of the car is 1,500 kilograms. It has an initial velocity of 30 meters per second. The driver applies the brakes to the car and it comes to a complete stop, meaning that our final velocity is going to be 0. And it skids for 60 meters. So we have some change in position of 60 meters. And we want to find the average force applied by the brakes to stop the car. So we're going to use work and kinetic energy to solve this problem. The first thing that we're going to think about is work is equal to force times some change in position, cosine of theta. We also know that work is equal to our change in kinetic energy, and that kinetic energy is 1/2 mv squared. So to do this, I'm actually going to set the work of force equal to the work of kinetic energy, meaning that I will have force times my change in position, cosine of theta, is equal to my change in kinetic energy. One thing I want to think about is, with work, this theta, the angle, is the angle between the force and also the change in position. So the next thing we want to think about is this cosine of theta. What's our angle? Well, if I apply my brakes to stop the car, what's really stopping this car is that my wheel is no longer rotating, so I have some frictional force that is slowing my car down, and then the change in position is going to be in the forward direction. So I need to consider what the angle is going to be between these two forces. So the angle between these two forces is going to be 180 degrees, making cosine of theta equal to -1. So I'm going to replace my cosine of theta with -1, which will give me negative force times my change in position is going to be equal to my change in kinetic energy, and I'm going to expand that out. So 1/2 mv final squared minus 1/2 mv initial squared. Because my final velocity is 0, I can get rid of that first kinetic energy term, and this will give me negative force times the change in position is equal to negative 1/2 mv initial squared. I have a negative on either side, so I can cancel that out. That means that force times the change in position is equal to 1/2 mv initial squared. And what I'm solving for in this problem is the average force. So I want to move my change in position over to the other side. The reason that this is an average force is I am considering the force over this change in position. So this is not a magnitude of force at a specific point in time, because we know that there will be changes in the total force happening on this object because it's slowing down. So this is why this is going to be an average force. So my average force is equal to mv initial squared divided by 2 change in position, and if I plug in the numbers, I have that the mass is 1,500, the initial velocity is 30 meters per second, and my change in position is 60 meters. This is going to give me a final average force that is equal to 11,250 newtons, and that's going to be the solution to this problem.